We're here at the Big 5G event in Denver, Colorado, and it's the after party version of these videos. I'm Phil Harvey. I'm here with heavy reading analyst James Crawshaw, and good to see you. And you've been chairing the AI and artificial intelligence, AI and analytics.
AI and automation, 5G, AI and automation.
I know I would get it right eventually.
Yeah, well, certainly we touched on artificial intelligence, we touched on analytics. They sort of are part of the same thing, really. And yeah, it was a good session. We had some service provider speakers from Verizon and from AT&T, and basically they were talking about the great complexity that 5G brings, and the only way you can deal with that complexity, unless you can throw a million people at the problem, is through more automation.
Right.
And some of the enablers of automation are AI and analytics. But it's also some technologies that we've had for a while, like SON, self-organizing networks.
Yeah.
But they sort of need to be revamped for the 5G age. And they talked about the challenges they're facing and what they're looking for, and they're still looking for solutions. So they're calling out to the industry. They want help with network planning. They want they want some real insights and analytics that can help them to decide where to put the next cell site, and they're looking for the ability to predict network faults.
I see this as being a big point of tension, because part of the attraction of 5G and sort of as we move to more virtualized networks and cloudifying network functions and that sort of thing is this idea that scalability will be on demand, that we'll just be able to sort of move the compute and the storage and whatever resources around to where the demand is. But here the operators are asking the industry for something a little bit different. They're sort of saying, actually it'd be really nice if we knew where those sites were going to be well ahead of time so we could put the resources in place. It's an interesting balancing act. They've got a really, really difficult problem to figure out here.
Well, that's right, but I mean there are some things that you can virtualize and scale up and down on demand and all of that, but you can't do that with a tower. You can't have a mast virtually appear out of nowhere with a concrete platform. Somebody needs to actually put down some bricks and dig a hole in the ground. So it's that sort of network planning where they still need some tools, some insights to help them ensure that they're getting the best quality of experience possible for the customer.
I don't know if this came up in the track or not, but are these things necessarily going to come from the telecom industry? Because I feel like people who do things in kind of mass market computing or maybe cloud computing or even supercomputing might be more, these problems might sound more familiar to them than they would to someone who is in the traditional network planning role of looking at things like population tables and rights of way and the way that sort of networks have been planned in sort of the old way of doing things.
Maybe they've got some new tools to bring to bear, but it's a pretty specific, complex domain, and there's a lot of nitty-gritty engineering and civil engineering, not even electronic engineering, let alone computer science.
That's where they're polite to one another, right? That's it.
Exactly.
It's always nice.
That's where they get the real work done. So yeah, there's some real basic, practical, very low-level type of challenges that need to be fixed. But in terms of cell site planning, it's about understanding. You might have a macro cell today of 4G. You're going to add 5G, but it's not going to be a 5G macro cell. It's going to be micro cells within that bigger macro cell. Right. And you want to ensure that there's seamless handover as you move from one micro cell to another. But figuring out, as you say, you've got to look at the distribution of the population, the footfall of traffic, to determine what's the best location to put that site. And then, of course, you've got all the challenges of actually getting access to that site. Is it a lamppost? Is it some sort of street furniture? And how do you get electricity to it? Lots of sort of very prosaic, mundane challenges, but they need to be fixed.
It's going to be, the war is going to be won in the trenches, as they say. Is there another takeaway from the panel in general about automation, or the level of automation that carriers need right now?
I think the takeaway is that everybody still has this goal of closed loop automation, that you have telemetry and other sources of data that you're collecting from the network that helps to identify where there are either things that are going wrong, or you need to simply add more capacity, and then that is automatically provisioned, or a network fault, you identify a remedy and you execute that remedy in an automated way. That's the long-term goal, but we're a long way from getting there. At the moment, it's very much an open loop type of control, so you use all of this analytics to identify the faults, identify the root cause, but there's still a human in the loop, because we're still not 100% comfortable of letting the computers completely take over. Because I always like to say to err is human, but if you really want to mess things up, use a computer.
That's a good place to leave it. All right, James Crawshaw from Heavy Reading, thanks so much for joining us.
Thank you.
Appreciate it.